is about Form 4 Chapter 1, Functions. If this is the first video you're watching this, you might want to consider not to watch this first, because first chapter function might be a little bit too hard to understand if it doesn't know about quadratic equation. If you're first time watching this, I'll try my best to make you understand and make it logic. In function, you get to learn about relationship. Now, what we will learn is here, for example, you're going to learn in chapter 2, you have an x and y axis, and you have a quadratic equation, and you get to know what is quadratic equation later. You have a curve of, say, an n curve. General equation, ax squared plus bx plus c equals 0. Now, for one value of y, says for any value of y, they are going to have two value of x. They correspond to two value, one x1 and x2. To get the same value of y. Here, there are two x value to get one y value. Over here, this will be many to 1, because your x-axis is where you start from. Many value of x to get one value of y. So there are basically four different types of relation. You have one-to-one relation. Now one-to-one is rather simple, which is a linear equation where you have one number mapped to another number over here. Assume there is a number here. One number to another number. One number to another number. One number to another number. One to one. Many to one, which is the quadratic equation. Many to one would be, says, one number to another one. Another number here mapped to the same number over the set y. You have two sets of number, set A and set B. They will be mapped to the same number. Many to one. One to many relation, however, one number, you get many, you get to map to 2 and above. This is one to many. Whereas many to many, that would be many here to here to here, where at the same time you get another number being mapped to the same number. This is what it means by many to many. These are the four relationships available. There are a few ways to represent it. This way I've shown you up here is through the arrow diagram. This four method is called the arrow diagram. Because the arrow in a diagram. You may represent it in a pair form, order pair, set form, or in a graph form. And we'll show you what does it mean later. Now next, if we get an example for how to look at it in the real-time question. Says you have one set of number, 5, 4, -4, and -5. I have one set of number, set A, is mapped to set B, another set of number, I call set B, 25, and 16. And then the number map, 5 is mapped to 25, 4 mapped to 16, well, 4, 4, 16, 5, 5, 25, maybe is the x squared for it. This is 5 to 5, 525. This is here. This is given in an equation. Okay, so you want to state the type of relation between set A and set B. Look at this. Well, we want to answer, no harm to answer it here. Maybe we'll give you some time to look at it. Reference to my previous page, page 1. You'll find that the relationship should be many to one relation. Many to one. Many to one. Two number to one. Two number to one. So its relation should be many to one relation. Now if you were to ask to find out, yeah, by using function notation, using function notation, this is the type. This is a function notation. How can you write that? That would be, if A is a set number mapped to B, therefore f, a function of an x number, is being mapped to the y, which is an x squared, where my x is here. This is my x. This side over the left is the x. This side will be the x squared. Now, there are some definition you need to learn. Over here, over the x is called the domain. What is being mapped onto to the right is called the codomain. Now, it's possible to have other number, say 16, maybe 32. Oh no, I'm going to write that here. Maybe I want to write, maybe another number is 32. It's in set B, but it's not being mapped. So, the domain is also called the object. It's also called the object. What happened? You map to this first two number over set B. The one that's being mapped is called the range. All the number in codomain are called image. We have object and image. Those that are successfully being mapped is called the range. Those that were used is called the object, which is the x-axis over here. They are related somehow. So, if you're using function notation, this is how you're going to do that. If you were asked to write them in order pair, in set form, good way to do, the answer should be curly bracket, 5 is 25, 5 map to 25, negative 5 is mapped to 25, 4 map to 16, negative 4 map to 16. Curly bracket, because it's in the set form. You may also represent, sometimes we'll ask in a graph form. So If you want it to be in a graph form, therefore, let me get another number in a graph. A graph form will be what I've used up there here, like a graph. Well, this is my positive y, positive x, this is my 0, middle. So we will expect it to be y x squared. You will know how to sketch a graph if you learn from 4 chapter 3. But for now, you just know it. This is my y equals to x squared. Okay. So what is being mapped? The range would be from 16 to I think I made a mistake here. -4 to 16. Oh yeah, correct. So maybe here is my -5, and here is my 5 symmetrical at 0. So the value is set here. So that's the range limit. Shouldn't exceed 5 because there's no other value than 5. Okay, here to here. So all the number that is being mapped is called the range. Well, this is an additional one, so it's in a graph form. So what is being mapped, what you have the y value of this is called the range. Because the maximum number is 25. Or the number over here is called object over the x. So this is what you have learned from 4 chapter 1. Next, now I'll give you some time to take a look at it. You may pause this video. Once you have downloaded it, you may pause it, have a look at it. Get to know the range and the reason to why I erase off this part here or here, because the range is from 5 to -5 to get the answer 0 to 25. Now, I'll get more into it in the next page. Next, you have a function and mapping. Over function and mapping, it will have function mapping. Now, in another occasion, you are given x, number of x maybe is 2, mapped to y, which is 5, and then 5 is being mapped to a composite function, z, in such a way that 2 mapped to 5, 5 mapped to another number called 8. So here, how could you interpret that? X will function of h, you get y. Y is a function of g, you get z, z function, a function notation. So here is an object, here y will be the image for x. 5, here is the image of 2. This is the object. If you look at these two, here, x mapped to y, this is an image. Image is the y value, x is the object. Refer to a previous. Image is the y over here. object, image and object, right? Now, over here, if you want to find out what is the inverse function, so inverse of hy is basically 2. Say for example, if you are asked to determine function h inverse of 5. Look at h, look at function h here. If you were to invert it, go backward, of 5, go backward, therefore the answer straight away can tell is equals to 2. Right? Now next, you are asked composite function h2. Now that would be, it looks so complicated, but it's not. Now, you look at the one towards the end. So here, GH2, H2, what is H2? H2 is H2. This is H, 2 is 5. So therefore, you may simplify this equation further, is actually G of 5. And what's G of 5? G of 5 is 8. Therefore, it's 8. Quite easy done. I mean, bonus question. The composite. All you need to do is substitute H2, what's H2, into the G, which is 5. Well, I hope it makes sense to you. This is on a mapping. Now, give you an example. Says what happened now. If you were given a function of w, it doesn't need to worry about this sign. It can be any unknown. It's just a function name. Just name it w of x. It's an object. Given a function is equals to 5 over 2 minus x. Now, please be careful. Please be aware that in order for this equation to be valid, your denominator, it cannot be 0. There's no way to be 0. So therefore, x can never be equals to 2. Okay? Because 1 over 0 is infinity. It does not need that. You can't do that here. So, let me repeat. This is some of those objective question, or paper 1. In order for inverse function, say 1 over 2 minus x, in order for it to be valid, you equate 2 minus x is equal to 0, cannot be equal to 0. Therefore, 2 cannot be equals to x. Okay? Let me rewrite this. In order for it to be valid, 1 over 2 minus x can never be equals to infinity. So therefore, 2 minus x can never be equals to 0. So therefore, x can never be equals to 2. This is important. You need to learn this. Now, aside from that, first of all, a question says find out what is inverse function for w. Well, you were not given of a map, so we're given a function. So how to do that? You need to use substitution. How can you use that substitution? You first of all first word let y is equals to the inverse of x. You equate it with y. Okay? So therefore, wy will be equal to x. I need to find out what's x, because this is inward. When you go backwards, need to find what's x. So therefore, my equation turns out to be phi equals 5 over 2 minus y will be equal to x. Rearrange them, you find out what's y. I will get 5 equals to 2x minus xy. Factorize them. No, I think I bring this over. I will get xy equals to 2x minus 5. So y will be equals to 2x minus 5 over x. Right? Therefore, thus, the inverse of x is therefore 2x minus 5 over x, where x can never be equal to 0. Okay? And first question, maybe second question, what's the inverse of 4? So therefore, that will be 2 by 4 minus 5 over 4, and the answer would be 3 over 4. It might take some time for this this part. It will take some time. This is a standard part. You let y is equal to that. Substitute it into the equation. Therefore, x. Then you find out what's y. You need to find what's y so that you get back from the front. Instead of x here, you replace it with y. Alright. Well, next we'll go into the composite function. Given hx is equals to 2x minus 3, gx is equals to, say, 4x, 2x maybe, 3x. Okay? So, in the question, find out what is g h inverse of x. A very similar question, but now you need to find out what is the inverse function. Right? Maybe I'll give some time to work out from your side. If you're working through it, maybe you will try to do it. I don't know. You want to try it? Grab some book, grab some paper, or you may pause this video while I proceed to do the solution. So, first step would be to find out what is h inverse of x. Again, I would let y is equals to h inverse. Okay? So, it's 1 over h, so I bring down the h, so therefore my hy equals to x. You may, to help you to memorize the steps, well, what to do, you need to memorize it. So you may, but it's not right. You may is 1 over h. So you just bring it out, This is not the right way, but it helps you to memorize it. because initially it's rather hard. As when you goes along with it, you try those questions, I'm sure you can handle this over time. Right, so I have hx is so therefore that will be 2y minus 3 equals to x. And then from here, summarize, it will be x plus 3 over 2. My y, I need to substitute thus and thus, therefore my h inverse of x therefore be x plus 3 over 2. Now, next, all you need to do is substitute the inverse of h into the g. So this is my g. So therefore, g h inverse of x will be, I substitute everything of her x with h inverse of x. So to do that, my g is 3. So 3 times my h inverse is x plus 3 over 2. That will be 3x plus 9 over 2. The answer will be the answer. Right? Inverse function, there are many variants of them. You really need to get the logic of it. There are certain examples, says inverse function where you need to look for the front given the back, front. So next I'm going to show you another function, another type of function given. You were given a function of fx is equals to 2x plus 5, and also given fgx is equals to x minus 3. The question here, you need to find out what is gx. Now this is interesting. Solution, you substitute the gx into the fx function, you get this answer. So therefore, my fx function would be 2 times my whatever gx is plus 5 is equals to x minus 3. Bring them around, rearrange them, therefore my gx would be equals to minus 8 by 2. So it will be x minus 8 by 2 would be my answer. One way, meaning you are given, the first one, the front, you are asked to look for the second one. Now next, given, maybe synchronized, then given. Another example, gx is equals to x minus 5 this time. And you were given also fgx is equals to x squared plus 5x plus 4. Now this would be a little bit challenging because now you are given gx, you will look for fx, look for the front function. You ask for, look for fx. Right, as for solution, f of gx is x minus 5, and the answer given to be x squared plus, the question given was the answer, is like this. So now this one you need to invert them, so you get the front. So what you do now is to let y is equals to x minus 5. Therefore, my x is now y plus 5. Fy is equals to x plus 5 squared plus 5, y plus 5 plus 4. Substitute into the equation. You've expanded, eventually rearrange them, eventually you will get y squared and so on. So you replace it with x, it will be x squared plus 15x plus 54. Right? Tricky part of it would be here. You need to use the inverse function, invert them, inverse them, and then substitute to get the answer. Right? The same is true if you are given the inverse function. And need to look for Sx. I'm going to show you on the next example. Given inverse of x is x plus 1 over 4. Okay? You need to look for fx. Okay? Now, here x plus 1 over 4 is equal to x, an unknown x. So again, you need to let y is equals to x plus 1 over 4. So x will be 4y minus 1. So my fy, which is my fx, therefore will be equals to 4x minus 1. Right? This is again something that is different method to solve those questions. It's going to take some time. You may download my video and then watch it when you are free and do some practice. Look for this equivalent question relates to them. Because next I'm going to show you the absolute value function, which is the last part of my video. The absolute value Now, absolute value function, which is a function that takes on the positive value only. Okay? Give you an example. Says you have a function of f of x is equivalent to absolute value x minus 3. Now what does it mean by x minus 3 and then you have this two functions? It means to take only the positive value of y. You may simplify it to the following. You have two equations. Original equation, you may take the original equation would be my x minus 3, and then another equation will be you times it in with a negative value. it turns out to be negative x plus 3. Right? Where if, when do you use this? If your x is greater than 3. So that you get always a positive number. And you should use this when x is less than 3. Alright? Now, to show it in a graph form, it will be much more easier to illustrate it over. Let me try it with a graph form. Okay? To do that, what it means, over here, I were to have a graph for explanation purpose. I'm sketching this over. 0 is a linear. Oh, okay. Mx plus c minus 3. So I will maybe here is minus 3. Maybe 3. So that I'll get gradient of 1. One line is here. It's supposed to go down. Dotted line, because I'll take only the positive value. You realize all the value here is the negative y value. In here, we only need positive, so I'm not going to take the value down here. Whereas for this equation, negative x plus 3, so 3, maybe here is 3, negative 1, so the gradient should go down from here, oops, and stops here. It doesn't go down any further because it's a negative value. This is what it meant. Two value, two graph. So this is f of x minus 3. So you need to be extremely careful when you deal with this value. But what happens when the number is 2? Okay, you find that when f2 value supposed to be 2 minus 3, which is negative 1, so therefore is negative 1. So therefore is 1. You apply a negative to it when the number is a negative number. You apply because it takes only the positive value. It turns out to be a negative value. This is a negative value. This is a negative value. If it's a negative value, you put a negative sign in front so that you get positive value. Alright? Now, you make it further, maybe from the range wise. If you want to look for the range, if I want it to be from here and to here, okay, let me design this question. Says if the number here is 2 and the number here is 4. Okay, so my working, I hope you don't mind. When f is 2, my calculation earlier is 1. Oh, it's not so logic because it's not scale. So here would be 1, not to 1. When f is 4, nah, I think it's it's not right, the scale. 4 minus 1, 4 minus 3 is 1, it's also 1. Nah. Let me do some amendment. Maybe I don't want to use true. I don't use 2. Maybe I use a number of 1. F1. So F1 minus 3, negative 2. Negative 2 times negative is 2. So the answer here is supposed to be 2. So the value here is 2. When F is 4, 4 minus 3 is 1. So here's 2. And the number when 4 is 1. So if the in the event when the domain of x of f is, so here I will write to say domain f learn, which is the x. Domain of f will therefore be from 1 to x and less than 4. Domain. So these are the domain. 1 to 4. Domain. And the range, and the range would be interesting because the range is now from here up to here. This is the range. The range of f is 0, start from 0, more than, less than fx, and less than 2. This is important to identify where is range, which is a domain for function. I'm sure you take some time to make it logic. And this is what it means by the domain over this range. Domain over 1 to 4, the range is 0 to 2. It's not 1, it's 0 because it starts from here. The graph from here, 0 to 2. Right? This is something important. I managed to highlight it over. You may rewrite these notes into a piece of paper, become your own notes. It will become handful when you're doing practice exercise. So that's all about it. In this Form 4 Chapter 1 functions, you may take some time. Each part of them, I hope you will stop this video, pause it, and would have at least 15 to 20 questions of equivalent format. Practice on it before you proceed to the next part. Absolute value, especially, you need to pay extreme caution because of the invert. The negative become positive part. And with that, I hope you will like my video. Press on the thumbs up button in YouTube. And I hope it helps you, and at the same time you don't mind to help the others by sharing this video with your friend or friends. If you have any question, you try to post it up to me. I will try to answer, or personal message me. I'll try to help you out with that. So that's all for now. Stay tuned for my next video. Thank you.